All right, page 375 in your textbooks now. And I want to talk about something that I believe I might have asked you to read over. I can't remember if I assigned reading. Yes, I did. Reading over something called a permutation. Permutation refers to, if you note this, the total number of ways or all possible ways that various objects could be arranged. Make sure you jot that in your notes because that's not spelled out quite that succinctly in your book. Permutations are the number of all possible ways, write this down in your book. That's what I just said. Listen and act. The number of all possible ways various objects may be arranged. The number of ways various objects may be arranged. For instance, it uses the example of 3 balls or 3 marbles. Well, you could put the red ball first, or you could put the yellow ball first or the blue ball first. But once you've placed that ball, can you use it again, class? No. Otherwise, you can't rearrange it again. So whatever ball was just used can no longer be the second one. Does that make sense? Now there's only 2 balls to choose from for that second spot. But once you've chosen, now there's only 1 ball left for the third spot. Does that make sense? So you could do red, yellow, blue. You could do yellow, red, blue. You could do blue, red, yellow. You could do a lot of different orders. What are they? Well, simply put, you'd look at the number of possibilities. For the first placement, there are 3 different ways you could place the first ball. Red, yellow, or blue. Whatever you pick, though, now there's only 2 ways to place the last one, or the second one. And then the last one is whatever it is. And so 3 times 2 times 1 gives us 6 different ways in which these balls could be arranged. If I wanted to line you all up, and let's take this, the kids who are in the back for us. If I wanted to line all 5 of you up in order, I might do it tallest to smallest, I might do it oldest to youngest, or I might just do it totally at random. How many different ways could I arrange you if I wanted to line you up along the wall? Well, how many of you could be the first person chosen? 5, because there's 5 of you here. The second person chosen, well, can't be the first person I picked, right? So he or she is out. That means how many people could be the second? 4. How many could be the third?
3.
How many could be the fourth?
2.
And of course the last person is just whoever it winds up being. So at your seats, how many different ways could we arrange the 5 of you in here?
120.
There are literally 120 different ways to arrange you. This is called a permutation, but you might notice this looks like something you should have done last year, right? What is it called when you take a number and multiply it by 1 less over and over again until eventually you get to 1?
Factorial.
Look at a factorial. Go ahead and note that term. It's on the next page. If all the objects in a set are going to be used, for instance, if I took the 5 of you and I said I'm going to put all 5 of you in an order, then that's a simple factorial. A factorial is simply the product of factors decreasing by 1 until the final factor is 1. Okay, a product of factors decreasing by 1 until the final factor is 1. And that's how you would find a permutation if all objects are being used. Now tomorrow, we'll look at, well, what if I just wanted to pick 3 of you? Maybe we had a race. Well, only 1 of you can be first place. 1 of you would be second, 1 of you would be third, and 2 of you wouldn't win anything at all. Sorry, Scott. Hey, we can't all be fast, okay? So don't let it bother you. All right, but anyway, so only 3 people would be winning. Well, now there's 5 people who could win first, 4 people who could win second, 3 people who could win third. But we would stop there. We're going to talk about that more tomorrow. Today we want to look at this idea of a factorial. Look at page 376. Page 376. Example 8.3a. 6 soccer players raced to the opposite side of the soccer field. How many possible orders are there for them to have finished? Well, if there's 6 soccer players and they're all finishing, we're not giving out prizes or anything, right? Because we don't give prizes to last place. But how many different orders could they finish? Well, 6 times 5 times 4 times 3 times 2 times 1. In other words, 6 factorial. And you should remember from years past that the exclamation mark means factorial. It doesn't mean, woo, we're excited about this, though you might be. I kind of am. We would write this 5 factorial, going back to the colored balls. 3 factorial, right? So that's the factorial notation. It just means take this number, multiply it by 1 less, then by 1 less, then by 1 less, until eventually you hit 1. Look across at the next page, page 377. On numbers 1 through 5, they simply want you to write this in factorial notation using the exclamation mark. Don't make this too hard. Numbers 1 through 5 take about 15 seconds. Good, Scott. Good, Lana. And Joshua. Class, how would we write number 1?
5 exclamation.
5 exclamation point. Read 5 factorial, but written 5 exclamation point. Number 2. 7 exclamation point or 7 factorial. Number 3.
4 exclamation.
4 with an exclamation point. Number 4.
6
with an exclamation point. Number 5. 20 with an exclamation point. Make sense? All right. Now I want you to find the value of the factorials in numbers 6 through 8. Actually find the value of the factorials in 6 through 8. All right, number 6, 4 factorial. What is the value when you do 4 times 3 times 2 times 1? Class?
24.
24. 2 factorial. 2. Because that's just 2 times 1. Now, here's where we can help ourselves out. 6 factorial means 6 times 5 times 4 times 3 times 2 times 1, right? But we already found that all that's just 24. So we're not going to multiply that again. We're just going to take the 6 times 5, which is new, which is
30.
and multiply that by 24 to get 720. So if you're working with a lot of factorials, once you've found a decent sized one, don't recalculate. So if I were to ask what's 8 factorial? What's 8 times 7 times 6 factorial, right? That's already 720. So I would just need to find the 56 and multiply that. You see that? So if you were finding higher factorials, be smart about it. Don't write them all out like that. Look at the next page. Page 378, number 9. Read that for us if you would, Joshua.
A bag contains 4 marbles, a red, a green, a blue, and a yellow marble. In how many possible orders could the marbles be pulled from the bag, one at a time?
All right. How would I write this as a factorial, Joshua?
4 exclamation.
4 factorial, 4 exclamation point. And so how many different ways could we pull the marbles from the bag?
24.
24, because we already found it, right? Good. Number 10. Read this one for us if you would, Lana.
A farmer is selling some crops in a farmer's market. If he has corn, tomatoes, potatoes, green beans, peas, and carrots, in how many possible orders could he arrange the crops?
All right, now probably he'll try to find the most beautiful way to arrange them, right? By contrasting colors and stuff like that. But anyway, how many ways could he do it? Well, how would I write this as a factorial, Lana?
6 exclamation point.
6 with the exclamation point, or 6 factorial, which means, class, how many different ways could he arrange his crops?
720.
720 different ways he could do it.
Wow.
Now, probably he's not going to overthink it. He's going to say, this looks good to me, and just put it up there. But technically, there are 720 different ways he could arrange those crops. Homework for this evening is to do page 379. Page 379, numbers 1 through 12. Page 379 in the homework section, numbers 1 through 12. We'll take a look at your quizzes tomorrow, and we'll continue talking about permutations tomorrow, but from the perspective of what if you don't use all the crops? What if you don't use all the cards? What if you only give prizes to the first few? That kind of thing. So we'll look at that more tomorrow. Have a wonderful rest of your day, and you are dismissed.